With a circle, remember, just finding the area, pi r squared, right? Circle with radius of 5, well, we're just going to do r squared, so 25 and pi, right? Simple as that, right? For a rectangle, we're just looking at base times height, so 2 times 3 is 6, right? And then finally, an equilateral triangle with a side of 5. This is the one maybe that will throw you for a loop. You have to do that 1/2 r squared sine theta thing, right? Because, you know, all the sides are 5, you know, all the angles are 60. So you can be like 1/2 5 squared sine of 60 degrees, and then throw that into a calculator. And end up with the following answer: 10.82531775 in the calculator. That's what they come up with. And from there, don't forget that just, you know, they don't tell you, so you got to round to 4 decimal places. We get 10.8253, right? So for today, we're going to move into the world of 3D and talk about surface area. Basically, all we're doing is we're going to look at all the sides, add up all the areas of each individual side, right? So we're going to focus on a prism today. Wednesday, we'll come back and we'll talk about pyramids. And then next week, we'll move into volume. All right, so here's a little bit of a visual. All we got going on here is these are all different prisms, right? We've got here is a prism with a base that's a pentagon, a pentagonal prism. Here, the base is a triangle, triangular prism. If you look over here, this one is on its side. Its base is a trapezoid, if you look at it, right? So they've got some words here. The bases are always going to be, if there is a shape that is not a rectangle, that has to be the base. So first of all, if you see one of the faces along here that is not a rectangle, that automatically has to be what your base is. All right? If all the sides are rectangle, like in this one, see how it's a even what we would think of the bases are rectangles, then basically my suggestion to you is just pick the one on bottom and be like, hey, that's the base. Okay? One of the other things that sometimes can be of help when you're doing stuff like this is to redraw the figure so that the base is on the bottom. See how here they're standing straight up? That usually helps to make it so that it's easier to see what's going on. It's easier to sort of identify all the things. You know what I mean? You know, like back when we were doing trigonometry, I would have you draw the triangle, especially if you were having trouble. You would draw the triangle so that the right angle was on the right-hand bottom side, the angle that you were using was on the left-hand bottom side, so you could know which side was the opposite, adjacent, and hypotenuse sides. Same idea here. It's not always going to be. It's not always going to be a big production. It's not always going to be difficult to figure everything out. But if you're in the middle of learning something, and on top of that, you're trying to figure out all these basic things, like, well, what's what? Then isn't it easier to just sort of trust that you know where everything is supposed to be? That's sort of my opinion on the matter. I would rather have them look like this, where they're standing straight up, base is on the bottom, so that you sort of can take for granted all the other stuff and you can just focus on the actual problem and identifying the pieces and moving on, right? That's my opinion on it. Lastly, on this page, this book, and this is, I never learned this when I was a kid, but they teach it now, so here it is. They talk about two different pieces of the total surface area. Like, if we're thinking about surface area just in general, we're thinking to ourselves, okay, how many square inches of wrapping paper do I need to completely wrap this shape tightly, right? That's what we're asking ourselves, like, okay, what's the area this side, this side, this side, this side, this side, all the different sides, right? The lateral area is just the surface area along the tube of the prism, right? It's basically, hey, if you don't count the bases, what's the surface area? Think about, like, instead of a normal cylinder, think about like a paper towel roll. You know how paper towel rolls don't have the end caps on them? And then you're asking yourself, okay, what's the surface area of that thing? So anytime they ask about lateral area, all you're going to do is you're going to ignore the base parts and only worry about the side parts. Does that make sense? And we're gonna talk more about that in a little bit, but that's the basic idea, if that makes sense. The takeaway from all this are how we name things. Remember that the base of a prism is, if there is one face that is not a rectangle, automatically that is your base. And then if we're talking about the height of the prism, we're talking about the vertical distance from the bottom base to the top base, which is like straight up. We don't care about no sideways, no diagonal. We just go from top to bottom straight up. One other thing that I'll slip in here, I will continue to rant about it later on, but this book is going to try and convince you that somehow there's a difference between when a prism has a base that's a triangle or a pentagon or a square versus when it's a circle. But it's not. It's all the same ideas, concepts, and formulas work. They're going to try and talk about it separately, give you this whole separate formula, and it's just more things that they're going to try and pack into your brain when you don't have to, right? So what I want to do is, before we get into like formulas, I want to go over just what's actually happening when we talk about surface area, right? Basically, one way you can think about it, imagine like you take that box and then you cut it up and you unroll it, and then you're just finding the area of all those pieces, right? We want to figure out what the area of that thing is. And in this book, they refer to that as a net. So if you see the word net when you're doing your problem, it just means I'm taking this box and I'm cutting it up and I'm laying it flat. So, like, for example, if I were to snip, I don't know, like along here or something, to open it up and then just lay it flat. Look at that. There two and there two, short. And just lay it flat. And what you get is I was one of those kids who just took stuff apart as a kid, much to my parents' chagrin. I was like 3 years old, and I was like, oh, they had a record player. I wanted to learn how it worked. And then suddenly they didn't have a record player anymore, you know, that sort of thing. kind of like that. So, but basically, if you think about how this translates into this, you've got all the dimensions, and it's basically just 6 rectangles, right? All of these, you've got this dimension is 5 all the way across, right? And then you've got this one, 3, 4, 3, 4, right? What have you? Nope. 3. Right, you get all that. And then you've got these 6 rectangles, you can just figure that out, right? So you go, all right, well, what's this? This has an area of 12, 4 by 5, this is 20, 3 by 5 is 15, 4 by 5 is 20, 3 by 5 is 15, 3 by 4 is 12, right? And then you just add everything up. 20, 40, 70, 80, 94, right? And what is that, centimeters squared? So it's kind of like that. You're just taking all 6 of those little rectangles that make up that prism and just figuring each of them out, right? And you don't have to leave it as this monstrosity here. You could literally just think about it as 6 different rectangles, right? Like, okay, what's this rectangle? Okay, this is 5 by 4. This is 5 by 3. This is 4 by 3. What's the area of those things? Oh, there's 2 of them each, so times 2, right? Like, there's 1,000 different ways to intellectualize this. There's 1,000 different sort of processes you can go through. But the key thing I want to break this down to before we eventually get to maybe more complicated ones where this would be a pain in the butt to do, is that regardless of how complicated it looks, this is basically what we are trying to figure out. Just taking all the pieces, finding the area of each piece, and then adding them all together and getting our area of the whole surface, right? The surface area. Give this one a try. You've got a right angle up in here. So we've got this triangular base has a right angle here at the top vertex. Notice that the prism is sitting on its side. You may or may not want to consider taking it, redrawing it so it's standing up so that it's easier to visualize what's going on. That's up to you though, all right? But figure out the surface area of each and of all the pieces total. Okay, so just be careful because you've got, this is 5, this is 6, this is 5, right? So let's find the, you can draw it out. Here's your 3 rectangles, and then you've got the 2 triangles, or whatever. This is 5, that's 6. 6, 5, 5. And this whole thing is 12, right? So 12 by 5 and 12 by 5, these are each 60. This last one here, 12 by 6, that's 72, ain't it? And then each of these triangles, if you look at the triangle, the base and the height are each 5, right? So 1/2 of 5 times 5 is, this is going to be really tiny to squeeze in there, but 12.5 to the 0.5. And then that's 12.5, right? So we can add it all up. We got 72, 60, 60, 12.5, and 12.5, right? You add those together. 1, 2, 7, 6, 12, 13, 14, 21. We end up with And those are centimeters squared. Yeah, 217. Y'all see what I did? Does that make sense? And I want to tell you, like, doing it like this is, even for problems like these, going to be not the way to go. Like, in a situation, this is, in a pinch, if there's literally nothing else that you know how to do, you can always break it apart. You can always break it down into just literally carving up all the panels of the prism and just doing each one individually. You have that ability. You are capable of doing that if you want to. But there is a better way. There has to be a better way, right? So here's how it goes. So the book breaks this down funny, but the general idea is there. We can make life simpler if we rethink how all these pieces are connected. What we can do is, we take the lateral part, the tube, and we take the bases and we sort of pop the bases off, put them over here for a second, and then look at the tube. And we realize after we open it up, the one dimension of what is now this big rectangle is the perimeter of the base, right? And then the other dimension is the height. So they talk about the lateral area, right, is the perimeter times the height, or lateral area. And then all we have to do is add on the two bases. Now they're gonna try and like have you do this in weird steps. I'm gonna show you a way to organize all of your thoughts and organize all of your calculations so that it's not just doing weird random stuff, okay? So surface area, we're gonna write it like this. And I'm in the way, I will move. So if you are going to sort of internalize one formula, this is a good formula to internalize because it's going to get you what you need. So 2 times the area of the base plus the perimeter of the base times the height of the prism. If you are able to figure out those things, this suddenly becomes much easier just in general to attempt to calculate. All right? And what we're going to do is basically we'll just take these 3 things that are in this formula and we're going to calculate them one at a time. And then we'll just take the answers and throw them into the surface area formula, and then we'll be good. In all the years I've been teaching, whenever I teach this, if a student just lays it out the way I lay it out, they always do great. Because you put all the stuff where it needs to go, and you don't have to like actually think about it very much. When I do these problems, I always start off by just writing this up here, just so I don't forget. And then I'm going to calculate each of these things individually. Some things it's literally just write the number down next to it. Others you have to ask yourself, okay, well, what's the formula for this thing? How do I find it? There's something missing. How do I get it, right? Like here, I want to find the area of the base. Well, okay, it's a triangle with the 3 and 4, right, for the base of the triangle and the height of the triangle. So, I mean, you can do sort of as little or as much as you feel like you need to. But like, and then the perimeter. Well, let me go back to the base. I've got this side is 3 and this side is 4. Wait, what's the third side? I don't know. Well, yes, I do. It's 5, right? So Pythagorean triple, if you remember that, you don't even have to think about it. You can be like 3, 4, oh, 5. Okay. You could also, if you don't see that, if you don't remember your Pythagorean triples, you could also actually do the Pythagorean theorem real quick. But either way, like I'm not grading, I'm not like saying, oh, they didn't write out the Pythagorean theorem steps. 2 points on, like I'm not there. However, you need to figure out that hypotenuse is 5, whether it's, oh, this is a 3, 4, 5 triangle, cool, 5. Or if it's, okay, I have to 5, okay, sure. But like, now I just do 3, 4, and 5 up to 12, right? So I've got the area of the base done, the perimeter done, the height is right. Now look, I got that, and that. They all go in there, right? So 2b plus p h, and then to calculate that out, right? 12 plus 72. So when you're doing this, one of the things that's going to make a huge difference is just writing out as much as you need to. But the way that sort of this is set up is you don't need to remember any like extra formulas except for this. And this will always work. As long as you know how to find the area and the perimeter of the shape that makes out your base, and you can identify what the height is, ta-da, you're good, you know? So it makes a difference, and I think it helps a lot, to be honest, to think about it like this and to sort of write it out in this way. I'm not saying it's the only way, and I'm not saying maybe it's going to be the best for every single human being on the planet, but it works really well for me. I think that laying it out this way makes everything super duper crystal clear. And like I look at this and I go, all of these things make sense to me, and I can look at it like as a unit and go, okay, cool, I get it. It also helps me a lot because I can go back and look at individual pieces independently of them, of each other, right? It's like, I don't know, did I do this part right? Let me look at this part. You know, everything is nicely labeled, everything is set up really well. And that's sometimes the difference between, you know, an A and a B, because sometimes, like, you screw up. Everybody does it every once in a while, especially me. And so for me, it's like, well, I can easily see if I made a mistake because everything's sort of very modular, right? So there's my sales pitch. If you don't like laying it out like this, that's fine. You still get 84 centimeters squared, you know you're fine, right? But to me, this helps organize me. I am a hot mess on the best of days. And so having something that allows me to stay organized makes a huge difference for me. So here's your turn. You're going to find the surface area of this guy. All right, folks, let's go over this. So once again, let's identify all our pieces before we do anything drastic here. So like, here's the thing. One of these is a pain in the butt to do. Let's save that till the end, right? Perimeter. We know perimeter is really easy because we know all the sides are 6, and there's 6 of them, so this has to be 36. The height is the distance from the one base to the other base. We know that's 12, right? Okay, now that we have all our other stuff, all the easy stuff, let's take care of the area of the base. So remember, we've got something like this. We're going to find one of those triangles and then times 6, right? So let's find one of those triangles. We know this bottom side is 6. This is an equilateral triangle that's made up when you get a hexagon, right? So that means that the radius is 6. Right? So, one of these triangles that's one triangle, ain't it? We just want 6 of those. Now, here's the part where, you know, it depends on you in terms of where you want to go from here. You could totally take that, throw it into the calculator times 6, and get this big long decimal that you have to write here, and then you have to write again a couple times. And that's fine. As long as you don't round, you know you're going to be okay. But, you know, and that's fine, like full stop. You could do that, and then there's no problem. If, on the other hand, you're saying to yourself, I don't want to have to write all those decimals all over again and again and again. You could just calculate out the coefficient part over here on the left. And you know there's 6 of them. So 6 times a half times 6 squared, whatever that is. And then you can just write it in calculator ready form. Like it's going to go in the calculator eventually, right? It's got to. But like, you can always wait and just leave it sort of in that gross exact form that we have. So you could say, all right, well, there's 6 of these. So 6 squared is 36. Half of that is 18. And then we're going to multiply by 6 again for the number of triangles. So this ends up being, and you can just leave it like that. 108 sine 60. Y'all see what I'm saying about that? Now, that is not mandatory. I'm not telling you that you have to do that, especially because there's basically just one more step anyway. You're just going to throw everything into the calculator anyway. But like, for some people, you're going to look at what you have to do and just sort of like, so there's 2 different ways that you can go about doing that. This is the way that I would go because I'm lazy like that. I know how my numbers work. I know how to leave things in just simplest calculator form, pre-calculator, and I'm okay doing the sort of the almost like algebraic manipulations that you have to do to deal with that. So I leave it like that because I know that's, for me, that like the path of least resistance, you know. But like for some people, I know that would be an absolute nightmare, and you would rather just do the brute force work of throwing that into a calculator getting like, I don't know, 80 something, whatever it is, and just writing that number over and over and over again, because that's less work for you. Totally fine. You better get the same answer that I do, but you should, right? Just don't round is the key. If you go to the calculator early, you got to use that whole decimal, because they don't give us any kind of directions as to how to round. So rounding has to be to 4 decimal places. So here, like we do this. And then now throw that into the calculator and you get your answer. Or, or not. Or you could have done, I'm going to write this down before I forget. But like, you could have done and gotten 93.53 whatever. But if you round, if you find this number right here, this 93 point whatever number, you got to use this whole thing right here. Yeah. So it's your choice. Where do you want the work to happen? Do you want the work to happen algebraically here, where you keep this and then you throw that in and then you figure it out? Or do you want your work to be in writing a big long decimal over and over and over again? Either way, you're not wrong, just don't round, okay? But this is what you get, and then again, we're talking about rounding to the nearest 4 decimal places. So like here, that 8 means we go up in 619.0615. My units are meters, so meters squared. Okay? I know this one was kind of a marathon, but conceptually, we feeling okay about this? Yes, sir.
Get the 100 page.
So this is one triangle, right? Remember that there's 6 of them. So we're going to sort of ignore this part for a minute and just do this. So 6 squared divided by 2 is 18, right? What's 18 times 6?
108.
Yeah, and that's where this 108 comes from. So now remember I said earlier, the book is going to try and convince you that cylinders are somehow different than prisms. They're not. Here's the only thing that makes a cylinder unique, is that instead of having any old shape as its base, the base is always going to be a circle. So a cylinder is a type of prism, and we're going to treat it as a type of prism. The book is also going to, try and give you an extra formula to have. And okay, sure, if you want to have this formula that you have memorized just to have a cylinder, great. But literally, it's the same thing that we've done. You're going to find the area of the base. You know that the area of the base is pi r squared. You're going to find the perimeter of the base. Well, you know the perimeter, that's just, circumference is just a fancy name for perimeter for a circle, right? So you know that this is going to be 2 pi r. And then the height. We don't need a separate formula for that. They're going to give it to you, but like, unless you are one of those people who likes to have every single possible formula for every situation all up in here, It's like, I'll even show you. So I like the picture. The picture is good because it shows you what we're doing, right? Same thing. But like, we don't need We don't need this special specific formula, 2 pi r squared plus 2 pi rh. This is the formula that they want for you. Right? You know, and again, some people, they like to have explicit, discrete formulas for different situations because they like having a toolkit that has many different tools that are very specific for very specific situations. And if you're one of those people, great. I'm not trying to, and I'm not trying to shame anybody either, right? Like, this is my personal bias of how much I hate memorization. As when I was your age, I went to music camps because, nerd. But I don't even memorize my music. Why would I memorize my music? I've got all my notes here. I know what I need to do. Here's all the notes, right? And the dynamics and the whatevers. And I actually ended up getting into an argument with the person who ran the camp because I was going to perform for my little thing that I had to perform. Well, you're going to memorize it, right? Why would I memorize it? Why do I need to memorize this music? Well, that's just what we do. No, why? The one time I memorized my music for a concert, I screwed up because my brain died halfway through, and it was like, oh God, what's the next note? Shoot. I am very, for myself, anti-memorization. I would almost rather just every single time refiguring it out from scratch every time, because to me, it's easier to understand what I'm doing that way. Not necessarily reinventing the wheel every step of the way, but breaking it down into the simple things that I already know. Because I already know pi r squared is the area of a circle. I already know 2 pi r is the perimeter of a circle. Why would I need this extra special formula when I already have the 2b plus ph thing, and I already know b and I already know p? He's pretty much only on YouTube now, I think, but there was a TV chef, Alton Brown, would always talk about unitaskers in the kitchen. Tools that you buy that only do one thing. This is a unitasker. Does this one thing, and why do it when you've got this thing that is not a unitasker? It is a multitasker. So that's my whole thing. Completely undercutting half of the stuff on here, But you do you when it comes to the number and types of formulas you feel you need to memorize. Some are helpful. Some may be less helpful. And that's a personal decision. That's a personal judgment call. I'm not going to tell you you're right or you're wrong, because either way, it's true. You're right or you're wrong. So we're trying to find the surface area of this thing. The base of the cylinder, the radius is 4 inches and the height is 6 inches. So let's find the area of the base. Let's find the perimeter of the base. Let's find the height of the prism. Well, pi r squared, right? Well, what is r squared? It's 16, right? So area of the base, 16 pi. Perimeter. Again, the radius is 4, so, and then the height we see is 6. So 2b plus ph, right? 2 times 16, 32 pi. 8 times 6 is 48 pi. Add them up, you get 80 pi. What are my units? They're inches squared. So, you know, I see that as easier, me personally. Someone else might come in and say, Mr. Webster, you're doing all this work when you could have just plugged in R and H to this other formula over here. Yes, that's true. That doesn't seem easier to me because it's more about the mental load of having to memorize all these different things. But, you know, you're going to get 80 pi regardless of which way you go. So do the way that you like better, do the way that works better for you, do the way that you understand best, and we'll all be happy. Okay? Your turn. Same idea. All righty. Once again, remember we're dealing with a circle, so the area of the base is pi r squared. R is 10, right? So 10 squared pi, right? And then perimeter is 2 pi r. So 2 times 10 pi is, and then the height, they just tell us is 9 straight away, which is great. And then I just do the problem. 2b plus ph. And then, so 2 times 100 is 200. 20 times 9 is 180. Just 200 and 180. 380 pi centimeters squared. Thank you. Very good. Yes? Simple? See, it's the exact same thing. Just because it's like specifically a circle and someone decided that it needed to have its own name, these are basically the same problems. It's just now they're doing just with the lateral area. And we're using a cylindrical stencil roller. We're just gonna, okay, we just want the lateral area part. So we just want the pH this time, right? No bases. So here they give you the diameter is 2.5, right? So, and the height is what, the 6? So it's just 2.5 pi times 6. Whatever that is.
13 pi.
Say it one more time.
13 pi.
13 pi. Thank you. All right. And then the same thing with this other one. Again, we just want the roller part. Now they're telling you the roller is 1.5 inches long instead of 6 inches long, right? But it's otherwise the same problem. So it's now it's 1.5 pi times that 2.5 diameter. That, oops, my bad. It is that 2.5 pi for our perimeter times 1.5. And then they want to round it to the nearest tenth. You already calculated it out? What did you get?
No, and then the one before was 15.
Oh, 15? Thank you. Yeah, 15. So with this one, Again, just 2.5 times 1.5 times pi. I'm gonna 2.5. We end up with what, like 11.78, yada, 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 round to the nearest tenth. This 8 means that we round up 11.8, and my units are still in inches, right? Inches